5%.
So if I go out here and I do 2 standard deviations, I will get 95% of the data.
I don't get it.
That's the definition of a normal curve, plus or minus. What's the definition of a dog?
A dog.
What makes a dog a dog?
It has 4 legs.
Has to have 4 legs.
Has fur or hair.
Well, that could be a
It's an
cat.
animal.
Okay, it has to be in,
And maybe a family.
It bark.
do all dogs bark?
No. Mine don't bark.
No, there's dogs that don't bark. So not all dogs bark. A Basenji doesn't bark. It has no vocal cords. It yodels. Okay, so barking is not a good definition for dogs, because not all dogs bark. Some dogs yodel.
It's a canine.
Has to be a canine. There's a category. So by definition, a normal curve plus or minus 1 standard deviation is 68% of the data. Whoops. Where'd that go? Plus or minus 2 standard deviations is 95% of the data.
Will this be like percentile?
Huh? What's a percentile? Is a cat like a dog? Percentiles are something completely different. Okay? But this was the definition of a normal curve. We talked about it and defined it. All our data, when we look at it, if it's a normal curve, a normal distribution, 65, so if we had 200 pieces of data, how many of them would be in the first, in that first area?
96%, 8%.
200 times 68.68
How'd you get that?
times divided by 0.68.
Huh?
200 times 0.68.
200 times 68%. So 136 pieces of my data would be between 55 and 65. That's all that that's saying. If it's normally distributed. We talked about all our we did talk about a uniform distribution. But when we talked about a uniform distribution, what did we say it looked like?
Take a mirror.
What did a uniform distribution look like?
The same in all those units.
So what would it look like?
More meaning.
Let's ask Google.
If it's a uniform distribution,
It's straight across.
everything, all my categories are equal. When we do the histogram, the bars are basically going to be equal. We talked about it. We talked about something that looked like
Let's go point
this.
this out there. We talked about a lot of stuff.
Yeah.
Now it's the test and we're trying to remember all of it. Sorry,
Yeah.
everybody.
So what did that distribution look like? What did we call it? We
Oh,
do.
You,
We talked about all the different, we talked about uniform distributions, skewed distributions. We talked about normal distributions. Just what the different distributions look like. And we defined the normal distribution. So when you make your histogram, you're gonna have to look at it.
So the symmetric is the one that has a 68%? That's the symmetric one? No, this is the symmetric.
That's a normal curve
Okay.
distribution.
Any curve that looks, that where the median and the mean can be symmetrical. But a symmetrical curve does not have to be normal,
Okay,
okay?
okay.
wouldn't that kind of look symmetrical?
This
But
would
that
look
looks
symmetrical, this would look something like, this would look like a normal curve. It could possibly be normal,
So the curve is like an imaginary line above all the bars per se.
yeah.
Oh.
But see, if my curve looked like this, this curve is symmetrical,
Yeah,
but it's not normal. Because most of my data is packed in the middle. More than 65% of my data is in the middle. So if it's it can still be symmetric and not normal.
And normal is when.
Normal is when 68% of the data is between plus and minus 1 standard deviation, and 95% is plus or minus 2 standard deviations, and plus or minus 3 standard deviations. You remember that one, Rachel?
Nope. Right down the chart. Refresh my memory.
90,
Three standard
99.
99.
Yeah. So plus or minus 3 standard deviations is 99% of the data.
With a few outliers.
So you can be symmetric and not normal. A uniform distribution is symmetric because it looks the same going both ways. A square is symmetric if I cut it in half. So symmetric just means that it's a mirror image of itself.
I can't remember how to do it. I think it was brief. It's all been brief.
okay, so how does that take us into this greater than thing? What is that? Oh, shoot.
So we sort of have to kind of cheat if I sort of look at, if I'm looking at a normal curve, right? Okay? If we know that this part is 68%, if we look at the whole thing at 68%, how much would be on one side or the other?
34?
34. So there's 34 here and 34 here, right? But I'm going to sort of cheat because this is where that ideal asymmetry comes in. I'm not going to look at that. How much of it is here? Below 60. What percentage is below 60? 50%, because it's the median, right? The median,
Oh, right.
So see, this area right here is 50%. This area here is how much?
50%.
34%.
Oh, that, yeah.
So if I'm looking at from here, from 65 down would be what percent? 84%. So if this is 84%, what's over here? 16%.
Thank you.
That is a tricky one to see if you remember about the normal curves.
You know, honestly, I don't remember you going over it this time around. I don't remember you going over any of those normal curves.
I might not have done this subtraction part.
No, you never.
Cause that's why I was like, looking for
Yeah.
I was like, wait, we skipped something. But, yeah.
But that's where I said, looking at what we're gonna start covering as soon as the test is over, I would be bringing this back in and talking a little bit more and doing some of the other aspects of that, because we were going to get into probabilities of continuous variables, and that's where we start to get a little bit more into this.
Could we hold off on this one for this test?
Well, you should be able to tell me the definition, you should be able,
68%.
So just the 68.
yeah, you should be able to do that, because basically, I think the question says, on the midterm says, a fish weighs the average weight of the fish is 60 pounds, the standard deviation is 5 pounds. If you have 300 fish, how many of them are between 55 and 60 pounds, or 65 pounds? So, 68% of the fish, yeah.
I think it's the wording that was against us. Like,
Yeah,
what are
it
you
is.
asking?
Yeah.
Yeah, this,
I'm
like I
trying to
said,
figure out.
these ones, and for the probabilities, that was what I had planned to actually do last class, and I didn't quite get to it, and I forgot to take them off. So that's why I said, as soon as I saw it, I went in, I told you. Now, this one, a little bit, because you have to remember when we defined what the standard curve was, and you guys forgot that from the first.
See, I don't remember, like Rich said, I don't remember.
I know I covered
You
the
said left
plus
cross,
or
you
minus.
left, skew right.
And I don't think I did, I might not have done the right, left, and part of it. But if it's full standard deviations, it shouldn't be too hard to sort of think about.
And then what about the next question? Says 50.
So the 50 greater than S is greater than 70, is that 0.95?
Yeah, because it's plus or minus 2 standard deviations.
So just
So
because
this would
those
just be
two,
95%.
because of 95%.
This one's a little trickier because it's just tail end, which means you have to sort of think about that 50 plus 34. This is just plus or minus 2 standard deviations. So this one is just 95.
Could you word it where it says
Percent. Huh?
Could you word it where it said 2 standard deviations?
No.
Oh.
You should be able to draw the picture and mark that out. 60, 65, 70, 55, 50. You should be able to step that out. So 95% is between plus or minus 2 standard deviations
On a normal distribution.
on a normal distribution. We'll talk about the student T distributions later on. Because I know I mentioned the student T distribution, so we talk about it later on. I named it, but I didn't talk much about it.
Will you
That's when
do,
we start squishing it and more of it gets in the middle.
Yeah, that's a little too much information for now.
will you go to 17?
And that's why I came in to tell you that we.
Yeah.
17, if you take 12 questions, this is the binomial distribution. This was that last thing that we were talking about.
Oh,
This one should be easy to do. This one is a little bit harder to do, and that's why I tried to tell Bronx.
Yeah,
Bronx.
we didn't get to that.
no, I got the
We were covering
top
other
part,
things.
it's the bottom part that I don't.
Okay. So if I'm going to do this, let me see, what is it? 12 4-choice multiple questions. Okay. So I just wanted to write that down because when I go and make it start playing on my whiteboard. First thing I'm gonna look at is what is my probability of being correct?
1.
No.
Right.
Probability of being correct. It's
One
a
out of four.
1 out of 4.
Huh?
Yeah.
It was four choice,
Questions.
multiple choice. So if it's a 4-choice, multiple choice question, you got 1 chance out of 4 of guessing correct, which is 0.25. What is the probability of being incorrect?
3 out of 4.
3 out of 4, which is 0.75. Okay, now, if I want to know the probability of having exactly 6 correct. So this is a binomial distribution. I've got 2 possibilities. I can be correct or incorrect. Okay, those are my 2 possibilities. Now, what I want to know is if I guess. So what I'm trying to do is I'm going to look at this and I want to know if I have 12 questions, I want to get 6 correct. I don't care what order I get the 6 correct, I just need to get 6 correct. So see, that's a combination of 12 things taken 6 at a time. So what's the form? So how do I write that? 12 factorial over 6 factorial times,
12 minus 6 factorial.
which means that if I look at this part, it's going to wipe out 6, 5, 4, 3, 2, 1, right? So that means if I'm actually writing this, I get 12 times 11 times 10 times 9 times 8 times 7. Divided by this, which is 6 times 5 times 4 times 3 times 2 times 1. So I have to do that arithmetic. And then to calculate the probability of guessing 6 correct is the probability of taking my combination of 12 things taken 6 at a time times the probability of being correct to the, how many did I want to get right? 6 times the probability of, now I'm going to write it a little bit different. I've said C prime. What does C prime mean? I could have come back up here and instead of writing incorrect, I could have wrote C prime. Remember, C and C prime are just the opposites.
Isn't it not to? You call it not?
Yeah. So incorrect is correct, not correct.
How come this
Thanks,
one
Mel.
cancels the 12 to 6 instead of minusing it and then,
Well, here I'm going to take the 12 minus 6. The formula, if I write the formula, the probability of n thing, of k thing, equaling k, is the combination of n things taken k at a time times the probability of being correct to the k times the probability of being not correct to the n minus k. I kind of should have not used 6 and 12. Probably should have used 13 questions and 6. Kind of gets a little bit, because 12 minus 6 is 6. So I accidentally get that 6 in there a couple of times.
okay.
Now, to be honest, I'm going to use